Good evening. Welcome to Discovery Place's virtual panel on artificial intelligence. My name is Gabo Jupan. I serve as the Senior Director of STEM and Exhibit Experience Development for Discovery Place, and will be your host this evening. We are so honored tonight to have with us three incredibly smart people who have done a lot of thinking about the ways in which we play and work with artificial intelligence. H.P. Newquist, Dr. Min Shin, and Sarah Williams. Before we begin, I want to give you an idea of the expertise that these folks bring to this evening's conversation. Dr. Min Shin is a professor of computer science and the chair of computer science department at UNC Charlotte. His research interests are in computer vision. He enjoys working with students at all levels, from high school to PhD. His recent AI projects include developing algorithm for finding potential cracks in nuclear power plants, measuring the level of social interactions using a smartwatch for helping stroke patients to recover better, and analyzing the movements of ants to understand how these social network insects work together, which may eventually help create a better AI. Welcome in.
Thanks for having me.
Thank you. From science and music to business and brains, H.P. Newquist has written more than 24 books for both children and adults. His books have received numerous awards and citations and have been translated into languages as diverse as Korean, Kanji, Arabic, Mandarin, and Indonesian. He has written about artificial intelligence for more than 3 decades, has written and directed music documentaries, and has spoken at events around the world on everything from guitars to smart machines. In addition to his writing, he is the founder and executive director of the National Guitar Museum. Welcome, HP.
Thank you very much. Glad to be here.
Sarah Williams is an associate professor of technology and urban planning at the Massachusetts Institute of Technology, where she's also director of the Civic Data Design Lab and the Leventhal Center for Advanced Urbanism. Williams combines her training in computation and design to create communication strategies that expose urban policy issues to broad audiences and create civic change. She calls the process data action, which is also the name of her recent book published by MIT Press. Williams is co-founder and developer of Envelope City, a web-based software product that visualizes and allows users to modify zoning in New York City. Before coming to MIT, Williams was the co-director of the Spatial Information Design Lab at Columbia University's Graduate School of Architecture Planning and Preservation. Her design work has been widely exhibited, including work in the Guggenheim, the Museum of Modern Art, Venice Biennale, and the Cooper Hewitt Museum. Williams has won numerous awards, including being named one of the 25 technology planners and game changers by Metropolis magazine. Check out her latest exhibition, Visualizing NYC 2021 at the Center for Architecture in New York City. Thank you for joining us, Sarah.
Thanks for having me. Excited to be here.
Thank you all, and please do provide feedback for us on Facebook as you've joined us. Please feel free to drop comments and questions for us, and we will try to share them with our panelists as we move through the evening. Min, let's start with, I think it might be good for us to just level set and make sure that we're all thinking about the same thing. What exactly is artificial intelligence?
Well, it's a really broad question, and it's an important question. Well, we'll just start it off by looking at authoritative source called Webster's Dictionary. According to Webster's Dictionary, it is a capability of a machine to imitate intelligent human behavior. Another way to put it is that artificial intelligence is a whole bunch of fields working together. So you can think of a whole bunch of fields that talks about how to sense the environment, such as what you can do with the image analysis or understanding speech and voice. And then second is the field of how you can manipulate the real world. And this can be such thing as robotics. And then there's a human and computers working together. So you might have heard of things like augmented reality and virtual reality. And then there are all these underlying mathematical algorithms that makes all this intelligence to happen. And that's what we call machine learning. But what's also important is that there are all these computer hardware that's really making this happen, and such as graphical processing units or things that you plug into your computer so you can play high fidelity games, or even massive computing powers like cloud and high performance computings. So one way to really think about artificial intelligence is this really broad area of computer science that are really working together. Then another way to think about artificial intelligence is two areas of artificial narrow intelligence, where this is where we're designing the machines to do a very specific things like smart speakers, self-driving cars. Whereas another is artificial general intelligence, where you really wonder if we can make machines to do almost anything a human can do. And that's another way to look at artificial intelligence.
Thank you, Min. So HP, when we think about the exhibition AI, Your Mind in the Machine, you were the lead on developing that exhibition. How did you get interested and passionate about artificial intelligence?
I actually was involved in AI back during its first commercial boom back in the late 80s and 90s, when the technology came out of labs like MIT and Stanford and Carnegie Mellon. And it died a spectacular death because it didn't do what it promised. Even back then in the 1980s and 90s, AI was considered something that would revolutionize and change the world. And the problem was, much as is true today, is that AI is really good at very specific things. Each application can do one thing tremendously well, but not a lot of things. For instance, an AI that can play chess cannot diagnose lung disease, and vice versa. So the first round of AI kind of imploded in the 90s and was taken over by research into the internet and the use of mobile devices and apps. But about 6-7 years ago, in the mid-teens, the 20 teens, around 2015, the power of computing expanded so dramatically that AI was brought back in to research and into corporations, because now all of the problems that had been obstacles back in the 1990s were now able to be taken care of, or at least gotten over, because we had cheap computing power. I mean, people today can buy a terabyte hard drive that's the size of you can put it in your hand. Back in the 1990s, a terabyte was as big as a refrigerator. So those things have changed. The speed of computing, as Min said, graphic processing units, all those things. Plus, the most important thing is there's a lot of data to help train AI with. Back in the 1990s, the biggest databases were with companies like American Express or with the IRS. Things that had your name, rank, and serial number, essentially. They had your address, your name, and some information. Today, companies like Amazon and Netflix and Facebook not only have your name and your address, but they know what you like, they know what you buy, they know who your friends are, they know what your friends look like, you tag all that. So AI got really big, again, about 5-6 years ago, because of all these things coming together, the power of computing, the ability to get all this data. And we decided it was time to kind of bring that out to the general public. And this exhibition, AI, Your Mind in the Machine, helps to kind of demystify what all the discussion about artificial intelligence is about.
Sarah, as we think about artificial intelligence, there's kind of a really important piece there, right? Which is this idea of the human brain and engineering a brain and engineering this artificial intelligence. So talk to us a little bit about what do we mean by the term intelligence in this case?
Wow, you know how to ask big questions, don't you? I think I have to go to a philosophy class to really dive into that one. But, intelligence has been defined in many ways. And I think some people say that it's the capacity to logic, understand, self-awareness, learning, emotional knowledge, reasoning, planning, creativity, critical thinking, and problem solving. And more generally, it can be described as the ability to perceive or infer information and to retain it as knowledge to be applied to adaptive behaviors within an environment. or context. Many believe there's lots of different types of intelligence. You might have creative intelligence, and I might have like a more logical intelligence versus people who have spatial intelligence. And I think there's, a lot of different theories about what exactly intelligence means, particularly as it relates to AI. When are we actually using computers to their full capacity, or when have we reached this kind of singularity idea? But I think it's a very hard thing to find, and maybe that's why it's hard for us to think about how it's applied to machines, right?
Absolutely.
Speaking of philosophy, Sarah, there's a great quote by a philosopher, a Scandinavian philosopher in the 80s, who once said that thinking about whether or discussing whether machines can think is like asking if submarines can swim. And when you think of it in that way, submarines do all the things that humans do when they swim, but are they really swimming? So are machines ever really thinking? And that gets to the core of what you said in terms of it is a philosophical question.
So we do have our first
That's
question.
why we all love Westworld, right?
Indeed.
Absolutely. We do have our first question from the audience, which I think is actually relevant to this topic. So I'm going to go ahead and bring it up. So Robin asks, I know we have seen it in the movies, but is there a possibility for AI to be advanced enough where it could think on its own and take over? And we are only 12 minutes into this conversation, and we are jumping into this. Could AI get advanced enough where it could think on its own and take over?
I will take a shot at that. You're looking behind Gabor at a picture of Frankenstein. And Frankenstein's a great example of man trying to create something that is like him and thinks like him and behaves like them. But to your question, almost everything that people know about AI is from the movies. And a large part of that has been true over 100 years. We had Metropolis back almost 100 years ago. The droids in Star Wars, certainly the Terminator, the recent movie Her, which was a personal assistant. Those are all the kinds of things that Min talked about, which are, we look at those as broad AI, not narrow AI. Right now, those things aren't really possible. We can do narrow AI, which again is AI that does one thing really well. For instance, diagnoses faults in a diesel engine, or helps you with your spell checker. But to try and get something that can do what humans can do, that's pretty far off, because we can barely get our own devices to work together. To try and get your iPhone to sync with your Mac or your PC, trying to get all the different parts of AI to come together as a sentient being. I personally don't see that happening in whatever is left of my life.
Well, there's an aspect of this that's goes to self-awareness, right? Could an AI be aware of itself, and maybe even thinking about that awareness? Min, you were going to jump in. Go ahead.
Well, this is really, really tough question, because it's really hard to prove what can be done or what cannot be done when we don't even know what is the current capacity in a lot of times. But one thing though, there's just a lot of broad opinions about when we'll reach artificial general intelligence, which is do anything a human can do. And some people say it's a decades away. Some people say it's hundreds or thousands of years away. So I think that we're just barely scratching the surface of really understanding what is what is artificial intelligence, what it can do. One thing is for sure, that in terms of understanding images, I think that we're barely getting to the baby steps right now, right? When we'll get to the teenager level, where you'll be able to synthesize a lot of things, watch videos, and really, we don't know. But I wouldn't say anytime soon, like the Hollywood movies will portray.
HP, one of the interesting things about the exhibition is that you would expect an exhibition about artificial intelligence to have just a lot of digital screens in it and a lot of digital interactives. But the way you've designed it, you have illustrated these concepts of intelligence using analog experiences. Share with us your thought process for why you would want to present these AI concepts using analog experiences.
Well, I think this goes back to the question that you just brought up, which about AI being self-aware and taking over the world. We have to realize that by and large, we don't really understand how we think. And one of the things that we bring to the exhibition is, here's how we solve puzzles. And we have puzzles that you can try and solve, and they're hard puzzles. They seem simple, but they're hard. But once you've learned them, you can do them again and again, and you recognize the patterns. There are other things that we do on a day-to-day basis that our brains process in such a way that we make sense of them. And a good example is optical illusions. And so we have a number of optical illusions which, unless somebody points them out to you, you're not going to be able to see them. But a machine could easily scan those. And by looking at those pictures and those images, it could find the pixels that are different from the ones next to it and be able to determine what is in those images. So it's important to us to be able to say, here's how we think. And here's how a human being goes about creating or making sense of the world and creating perspectives. Yet here's how a machine does it. And a machine does it by and large through recognizing patterns and recognizing anomalies in those patterns. So if something is wrong, it can point it out. If everything looks the same, it can identify something that might be a little bit changed. We have a screen that shows about 100 different images of a small guitar. And one of those guitars is different, just one. And it takes 5 minutes to try and figure that out, to figure out which of those small guitars is different. But a computer can scan that in a fraction of a second and identify the one that's different simply by seeing the pixels that have changed between the first and second. So we really want to show, here's how humans think, here's how machines seem to think, and how do we work to bring those universes together.
Great. Let's shift a little bit to application, right? Because you guys all three of you have some really interesting applications of artificial intelligence and the way that you use it to further the research that you're doing or the work that you're doing. Min, tell us about the focus of your research as it pertains to artificial intelligence.
Sure. My area of research is called computer vision, and pretty much it's really mimicking what human does with eyes. So for computer vision, the eyes would be cameras and brain would be computer and programs or algorithm that runs underneath. So in two broad sense, there's one research area that I've been working on, which is if you provided how to analyze the motion of how things are moving in video. So you can think of it as input of video and output of like how this is how all of these things moved around. And there's, I don't work on it, but there has been a lot of work on understanding how pedestrians are moving, for the obvious application of self-driving cars. Mine is actually by working with the biologists, how to understand the movement of social insects. Well, when I told that to my kids, they were like, Dad, who cares about them? Well, what's really interesting is that these social insects are incredibly decentralized on how they work together, but they're incredibly resilient to adversaries, challenges that comes their ways. And, if you own home, you know what I'm talking about. So the idea is, can we not only understand how these social insects move and work together, and what biologists needed was some ways of gathering an amazing amount of data. And rather than human to follow these, we're building an algorithm and computer that will actually follow and analyze emotion. And at some point, if we have a good understanding of how these social insects work together, maybe we can make computers that are much more robust by applying these algorithms that the biological objects are doing. And the whole field is called bio-inspired computing. That the second is what we call social bit. Fitbit tells you how many steps you take, and I'm wearing the social bit. And social bit is an app that runs a smartwatch. They'll tell you how many minutes you socialized. And it's in collaboration with a neurologist at Harvard Medical School and a psychologist at University of Arizona. And just like Fitbit, it's trying to encourage all of us to be healthier by walking more. SocialBit is to encourage stroke patients, at least for now, to be healthier by socializing more, because stroke patients tend to isolate themselves, which hinders them from recovering faster. So those are a few research projects I've been working on. And one thing that I'll tell you is that I'm a just typical example of AI people that are not just doing the computer science-ish things, but we tend to work a lot with very, very different disciplines of science and so on.
That is fascinating. And those of you who have tuned in to hear about ants and AI, I think you've definitely found what you were looking for. So that's fascinating. I'm sure E.O. Wilson would be interested in your research if he's not already following it. Sarah, you also have some really interesting applications of artificial intelligence, both in your direct work and the center that you lead. Can you talk a little bit to us about your work around urbanism?
Yeah. Well, so first of all, much of my work, as you mentioned earlier, really focuses on how we use data to affect policy and change policies, or really create change in urban environments. And one thing that might be ironic while we're talking about AI is that a lot of what I look at is missing data to answer some of those questions. And, it might surprise you all to know that, many places in the world, we're basically lacking essential data on where people live, deaths and births, just even basic information on the roadways. So I apply AI a lot to satellite data, to actually, and also data that I've gotten through partnerships with Facebook and others, to actually create basic infrastructure data that's essential for making decisions in many places. I do a lot of work in Africa. So one example in my early work is I made the first GIS or roads data set for Nairobi, Kenya, created the first land use density maps of Kenya. And in fact, I've been working a bit with Facebook's Data for Good team to increase this. So if you can imagine really creating the first worldwide, very high scale, detailed population map. And by having access and knowledge about where these populations are, we can better plan resources. And this is coming up right now. I'm doing a lot of work with Sierra Leone on vaccines and how to do vaccine distributions, and understanding where those rural populations are and how to get to market is a really important part of the work that we do. And in fact, we're using many of the vision kind of tools that Professor Shin was talking about in the applications that we use on satellite imagery, and then we can combine those with some of the big data sets that Facebook has. We also do lots of fun projects in the lab, the things that you might not think of as using AI. One that was fun that we did over the summer is, people might not know this, but New York City is going to have an election next year, and actually 40 out of the 50 city councilmen are up for re-election without an incumbent. So it's going to have a huge change. And we wanted to try to explain to people, what do the city councilmen do? What are the topics that they discuss? And so we scraped every article from newspapers in New York City from the last 20 years, and then we ran it through a topic modeler, and a very simple AI topic modeler, to get the kind of topics that people have talked about over the years. And actually, I'll just put a link to the results here so you can see it, which we made into, I just put it in the chat, which we made into a data visualization. Maybe I'll share my screen so you guys can see it. This is just a lot more fun way to try to get people interested in politics, right? So we can see topics. The biggest topic is education, policing, elections, but we have smaller things that they talked about, such as the foie gras ban and the plastic bag ban. But you can see these different topics over time, and that's all by kind of running it through a very simple algorithm that all of us is open and accessible to all of us right now. So I think really, the way that we apply AI is really thinking about what is the question that we want to answer, and what are the AI tools that might help us do that.
That's really interesting. And it's such a different facet of this, right? To show the data visualization and the use of AI to reveal things that otherwise it would be much more challenging for us to see, because it's revealing those patterns, right? That HP talked about previously.
Yeah, I mean, and I think that's what's so great about AI, right? Is that it's excellent at finding patterns and can do it much more quickly than we can as humans. And so I think that whenever people are talking about like, well, what is the future of AI? It's like, well, what kind of patterns do we see in all these new big data sets that are emerging right now? Even the data sets of autonomous vehicles, like we just yet to tap into the kind of patterns that we'll see coming from those autonomous vehicle data sets.
That's great. And I think it's a great transition to a question from Christian. And that question is, often I find that machine learning and AI are used interchangeably, but isn't machine learning a subset specialization of deep learning? If so, do you anticipate the future of deep learning to be the modern industrial revolution?
We could all jump in with, yeah, machine learning. When you get into definitions, machine learning is an area of artificial intelligence. And machine learning is really a process by which machines are programmed with algorithms, and certainly my two co-panelists can talk to this more than I can in detail, but machine learning is essentially setting a series of algorithms loose, for lack of a better term, and letting them find those patterns that we're talking about. And by finding the patterns and establishing a goal, can you find the dog in these pictures? Well, show it 1 million pictures of dogs, and then show it a picture that it's never seen before. Has it learned to identify what makes up a dog? So being able to learn on its own is really a function of the math behind it that allows it to establish patterns that it can see over and over again, even to the point where when it's shown things it's not seen before, it can recognize that as, for instance, a dog. So yes, machine learning, certainly a part of AI. I'm going to let my panelists go from there.
If I can add on to that, we use whatever word that is kind of trendy and, get attentions, and maybe some companies are willing to get some venture capitalist money. AI is definitely one of those terms right now. So definition, I would agree that typically we consider AI to be a little broader than machine learning. And machine learning tends to be a core algorithm that gets applied not only to AI, but also what we may consider to be data science. So the question of deep learning, is that the next modern industrial revolution? Well, deep learning has done amazing magic to bring the second renaissance of AI. The capability of deep learning is quite fascinating, and we've seen a lot of progress in that. However, I think that it is important to understand that there's one aspect of what we'll call just traditional deep learning that one thing that we are lacking is, what is it really learning? And being able to interpret and understand what the deep learning algorithm is learning would help us to be able to have being able to trust the AI system. And that's something that I'll definitely talk about a little bit more later. But I think that for the deep learning and so on to definitely have the lasting impact, I think that being able to interpret the data and understand what it's really learning is a really huge key. And so some people call it trustworthiness of the AI or deep learning, which is really important key here.
Absolutely. Thank you for adding that. HP, I want to kind of go back to your story and the things that you have been working on for the last 30 years. You're the executive director of the National Guitar Museum, and yet you're here on a panel talking about artificial intelligence. There must be some really interesting relationships and overlaps and conversations that you have as you think about kind of those two things of guitar, of music, of artificial intelligence and technology. Talk to us a little about how your study has maybe converged or overlapped or spoken to each other over the last 30 years.
You know, like many people who played music in college, I had great aspirations of taking my guitar and making millions of dollars and being famous. And the reality became that that wasn't going to happen. But I was incredibly interested in AI. My father had worked in the computing industry in the 1960s and 70s. And so I was familiar with it. And at that time, in the 1980s, a lot of music was getting digitized or becoming digitally operative. Things like synthesizers and computers working together. And so I've been able over the decades to kind of keep both of my passions together. But in recent years, I'd say literally within the last 4 or 5, looking at AI from a creative standpoint has really become very popular. And in the 90s, we didn't think of AI as being creative. We thought of it as being a mimic, something that mimicked the expertise of a doctor or an accountant. But now there are a lot of people working on AI that appears to have creativity. And in the case of our exhibit, we have one particular interactive called the AI Painter, which basically is filming in real time what's going on around it. So if you walk in front of it, it sees you. But it will paint an image of that scene in a variety of different painter styles. So for instance, it will do it in pointillism, it'll do it in impressionism, it'll do it in cubism. And it'll do that while you're watching it. And it will look like it was painted by Monet or Van Gogh or whoever. And people, if you take a picture of it and you hold it up, you'll ask, is this creativity? Well, is it? I mean, it's made an interpretation that's never been made before, but it begins to open up that discussion about, is what the machine doing something that we would consider creative? And that makes the philosophy of what is AI, what is intelligence, what is human behavior, expand exponentially. So we've found some really great things in music as well. There's some great online tools that have actually mimicked Frank Sinatra without using Frank Sinatra's voice. So creativity in AI, is it creativity? Is it the machine? Open for discussion.
Well, and when we start blurring those lines, right, that's when we start getting close to concepts like the singularity of who created this? Did the machine create it, or did the human create it, right?
Or is it simply a function of mathematics? And a lot of it boils down to the math behind.
Can we assume that the music we hear on the radio today, or maybe tomorrow, may have some AI has been used in the creation of that music, or is that far-fetched?
I'm old enough to think that if AI has anything to do with the music today, that we should just stop now. I don't think AI really does yet. There are certainly some programming tools that help make it the production of AI much easier. I'm sorry, the production of music using AI much easier. And as I said, there are some tools on the internet where you can apply AI as a backing band, perhaps. But I don't think yet the things that we're hearing in pop culture yet really have much of a basis in AI. That's not to say that 5 to 10 years from now, it won't happen, but it's not quite there yet.
So Sarah, we've got a question from the audience that I think could really tee up the next question. And the question comes from Josh, who says that I assume AI will more than likely be utilized as autonomous weapons for countries' militaries. It will most likely create another arms race and creating yet another threat to humanity. And his question is, do the pros outweigh the cons? And I want to kind of use that question as a jumping off point to ask about some ethical questions of artificial intelligence development. So as we're getting into and thinking about, oh, the possibilities of artificial intelligence, what are some ethical questions that we should be thinking about related to this development and its application?
AI brings up huge ethical concerns, and I think one thing we forget is that how it's developed represents the ideologies and the positions of those people who make the algorithms. And so in a way, we often think of computers as being, let's say, not having an opinion, but they do. They have the opinions and ideologies of those people who program them. And so I think these are where many of the concerns come up for AI and ethics. So hopefully we won't have somebody who wants an arms race programming an arms race, but I think more broadly, this is where we come up and, I'm not sure how many people are familiar with the Timnit Gebru case. So this is an AI ethicist that was working in Google who was recently dismissed because of some of her findings, which illustrated some bias in some of their algorithms. And I think that as much as we are developing algorithms, we are going to be including those biases, and that it's really important that we embed these ethicists in companies such as Google and Facebook to help bring those things to highlight them, to help the companies really change and modify them. So I was very surprised at her release, because they do hire those people just for that purpose, to help understand or expose the biases that are hard for us to identify as we try to make balanced algorithms. But no matter how hard we try, they're always going to come from a position. Another great illustration of bias in AI for people who might not understand it is, facial recognition software, right? And that there's a lot of bias in order for us to recognize things in images, we have to give it a lot of training data. We have to train the computer what to see. And, there's a lot of bias in that training data. And so one of those biases exposed that we don't do as good of job as finding African Americans as other ethnicities because they're not in the training data. And so there's so many things that we need to think about. The training data, how do we train? So it's not just the algorithm, but how do we train the algorithm? And that training also represents all of our biases. And so we really need to think about how to create those checks and balances. And that's why it's so important, whether it's Facebook or Google or others, to have those ethicists embedded within the company to really help pull those potential biases out.
Thank you. That's really weighty and important stuff. And we do have our next event actually is going to be March 24th, where we'll be viewing the film Coded Bias and having a little bit of a discussion around some of these themes as well. So thank you for raising them. So let's shifting a little bit to some fun reflection as the Artificial Intelligence, Your Mind and the Machine exhibition does a great job of telling the history of AI going back, as you can see behind me, Frankenstein as being an example, but there are many, many more of how humans have imagined these artificial intelligence and these pieces. So I'd love to just go around the room and have everybody share your favorite moment of AI history or culture, right? We've talked about how important movies are as well. So what is your favorite moment of AI history or culture? And I'll go left to right on my screen. HP, you're first going left to right. So I'm going to ask you to lead us off.
I've got many, and there's examples throughout the exhibit, but I think I'll stick with Frankenstein right there. I think it's really insanely important, and also just intriguing and interesting that a story written by a teenage girl 200 years ago is really sort of the de facto image concept brand of humans trying to develop another intelligence run amok. So I think that by reading Frankenstein and what Mary Shelley did, again, a teenage girl in Britain, creating something that we still utilize today as being part of man's hubris and trying to either play God, if you want to say that, or trying to create something that God should only create, or creating something just like ourselves, is still relevant. And whether we look at the Terminator, or we look at Westworld, or we look at the Forbin Project, or any of those great movies, all of them have a little bit of Frankenstein in them. So I have to kind of default to Mary Shelley's original creation, which again is Frankenstein's monster, not Frankenstein himself. So the monster itself, I think, is the moment that I would default to.
I love that, and I love that you called out that this was a teenage girl who wrote this novel that has echoed throughout time in so many different ways. And Sarah, this, I can't help but think of our earlier conversation about what an important role women are currently playing in the development and the leading of AI. Talk a little bit about that, as share with our audience what you shared with us. And then I'll get to your favorite moment of AI history.
Yeah, well, it's funny because I'll actually put, I think for me, I'll put in this chapter is Kismet. And Kismet was one of the robots that kind of responded to emotions. But I think maybe why it's more near and dear to my heart because I was at MIT in grad school at the time, and that was really my first introduction to like the power of AI. So maybe it's a more personal but exciting experience to see a robot responding to impression. But this is a woman AI scientist from MIT that created that. And in fact, this year, one of the MacArthur Genius Awards in AI goes to, again, one of my colleagues here at MIT that's really applied AI to thinking about issues of breast cancer. And it's just such an inspiring story because she is a survivor of breast cancer herself and really thought like, how can I apply this tool that I know so much about to really helping save lives? And she's made major accomplishments in this area. So I just think many of my colleagues or faculty who are really important to AI here at MIT are women. And just thinking about National Women's Day being March 8th, I just want to really highlight that fact as well.
Absolutely. Thank you so much for sharing that. Min, your favorite moment of AI history or culture?
Well, there are two, they're all both coming from 1960s. So, well, here's a quote by Herbert Simon, was one of the pioneers of artificial intelligence, winners of Nobel Prize and Turing Award, which is kind of equivalent in computer science. He famously said in 1965 that, quote, machines will be capable within 20 years of doing any work a man can do. Okay, so that's from 1965. Now, the second one is that in 1966, this is where the whole field of computer vision actually started. Then Marvin Minsky, who was a co-founder of MIT AI Lab, also a Turing Award winner, had a vision that, hey, maybe we'll have one undergraduate student to work for a summer to kind of solve general computer vision problem that if you take a picture, you'll be able to recognize what's in there. Well, we certainly realize that it takes a little more than a summer and one undergraduate student to work on it. Well, the takeaway is that even though we can kind of do the Monday quarterback and say, well, we can all laugh about how off these pioneers were, but I really, really think that these kind of optimism and just, the idea that things can be done is what really has driven AI. We're definitely realizing AI is not easy, but we have making a huge stride. And I'm really excited about what's going to come next in next several decades or more.
Absolutely. So that was fun to reflect with you all on the history of AI. But I think to close us out, I think it would be remiss if we didn't imagine the future a little bit more. And so I'm going to go back to a question that one of our audience members, Aaron, asked. What is the potential use of AI are you most excited about? And let's go in the other direction this time. So I'm going to ask Min to start us off this time.
Well, well, one thing that if I ask my children, what are they most excited about AI in their lives, they will say no more cleanup. I mean, Roomba has done wonders. And if Roomba can do vacuum cleaner within 10 years, can you imagine what it can do? I mean, would we be washing dishes ourselves? So there will be a lot less, hey, you got to tidy up and clean up stuff in near future. Definitely transportations will change. Healthcare will definitely change a lot. And, we're hearing a lot about farmings, and then all these agricultural that instead of spraying and fertilizing entire tons and tons of acres, can we actually have small drones that's going to actually understand exactly what each crop needs so that you can actually be not only be resourceful with the water and so on, but also be very environmentally friendly. I think that overall, what I'm really looking forward to is how AI and machine and human will work together. It's really not about AI replacing human. It's really about how AI will work together with human. And there's a lot of research that needs to happen and that's happening, where how we build a human-centric AI so that we'll end up creating a whole bunch of new jobs that we have never seen before, that will empower people to do a lot more creative things by using AI as their companion. So I really look forward to that.
I appreciate it. That actually sounds like a challenge for us to imagine and to think about this AI as a collaborator. So I love that. That's great. Sarah, what about you? What are you most excited about?
Well, as an urbanist, and kind of Min spoke a little bit to it already, I'm really excited about thinking about autonomous vehicles and really their potential to change our cities. I guess, as I said earlier, I'm really interested in how AI affects our culture and affects policy. And I think it has huge potential to change the way we navigate how we use public spaces. Think about, we might not need parking anymore. What does that mean for our cities? That it frees up huge amounts of space that could be used for parks, for other kinds of vehicle, but also to really could we reduce traffic forever? Can we really optimize the traffic jam using autonomous vehicles? But I think even more exciting than just the potential of AI on the roadways, which is a very near future potential, which is really exciting, is all of the data that these vehicles develop. And the potential for us to mine and use that data to really understand city phenomenon and processes, and even help people on the margin. So Microsoft is using some of that data to help guide blind people through the cities, through audio. And so I really think, this data that's created from autonomous vehicles is going to be a whole new infrastructure that we can tap into and use for all kinds of things. And I think it's going to be, similar to the internet when it was coming out. It's kind of this new framework in which we'll build upon. So that's super exciting, I think.
Absolutely. That is pretty exciting. And I will definitely agree to that autonomous vehicle and all of the potential. That is pretty exciting. HP, what are you thinking about? What are you excited about?
Well, I have to highlight two of the things that were just mentioned. One, getting rid of traffic. Living in New York City during the pandemic and seeing the cars drop off by 70-something% made the city an amazingly wonderful place, regardless of what was going on around us. But not having traffic in and around the city was a wonderful thing. And ALVs, autonomous vehicles, will help usher that in across the country. And with what Min said, I think healthcare is going to be extremely important. You know, there's no doctor in the world that can keep up with all the advances that come in their respective fields. There are thousands of papers produced every month in every field, and no doctor can keep track of that. And if we could have AI keep track of that and at least feed that information back to doctors, I think we get ahead of some treatments for diseases. And I think we're even seeing that with some of the development of the COVID vaccines. Personally, I think extending AI is a sort of as a companion, as Min said. I think that the idea of everything we had with our cell phones, talking to Siri, having everything on there, communicating with Siri, but having an AI that knows a little bit more or anticipates more what we want from our daily lives and alerts us to things that we would be more interested in than not. Things that help us get through our day and give us more free time. I think that's the immediate thing I'm looking forward to of applying AI, at least in my life, without looking, 30 years down the line where, it's doing my dishes or whatever that might happen to be. But I do think being an assistant, having an AI as a smarter assistant going forward is something I'm really looking forward to.
Well, those are all really, really exciting developments and things to keep in mind as we optimistically look toward the future as AI as a collaborator, as a partner. So that is all the time that we have this evening. Thank you so much to our panelists, Dr. Min Shin, HP Newquist, and Sarah Williams, for lending your time and expertise to this conversation. Where can people connect with you all if they want to learn more? Min, how can people connect with you?
I can certainly share my website information. I can do that. And they can actually just search for Min Shin at UNC Charlotte, and they should be able to find me.
Sounds good. Sarah, how can people connect with you?
You guys can connect with me at DataSo on Twitter. I just put that in the chat.
At DataSo on Twitter. Thank you. And HP?
You can find me at newquist.net, my last name, newquist.net, or by Googling HP Newquist. And that's got information on the exhibit as well as my books.
That sounds good. Well, thank you all again. If you have not had a chance to visit AI, Your Mind in the Machine on exhibit at Discovery Place, we would love to see you there to continue this conversation. Also, be sure to put March 24th on your calendar for our next event, Coded Bias, a viewing of the film and an accompanying keynote. Thank you again for joining us, and have a great rest of your evening.
Thank you.
Thank you.
Thanks so much.
Thank you.
Bye, guys.